Okay, we're going to work on problem 21. 21 is identical to the last problem we just did. The only difference is this time the object that's falling is water instead of a baseball. So we're going to solve it in exactly the same way. We have a velocity of 4.5 meters per second to the right. We're told it's falling 53 meters, and we want to find how long it took to make that fall. And we're also asked in part B to find the range, or the horizontal distance traveled. So same equation as with the previous problem, and it comes from, just to remind you, this is the chapter 3 summary page. It's this equation right here, which is the same as the equation from chapter 2 right here, except they're just using the same equation applies either in vertical or horizontal. You just change the x's to be y's and the vx to be vy, and etc. But the same relationship applies vertically and horizontally. So in this case, I'm using this relationship right there and substituting in the values. So there's my equation. Of course, I know my initial velocity is 0 because we are starting off with only a horizontal velocity, no vertical component, so that whole term goes to 0. They substituted in the letter g, which just basically means acceleration in the y direction, which is acceleration due to gravity, so they put the g in there. Alright, so what's my change going to be? First I'm going to rearrange and solve for t, and I actually substituted in first, and then I realized I should have rearranged. So then I rearranged and substituted in my values. And what do I get? I actually didn't do it on the calculator, so let's try that. 2 times 53, square root of 2 times 53 divided by 9.8 equals, and I get 3.288. How many significant digits do I need? It looks like I need to keep about 2 significant digits, so this will be rounded to 3.3 seconds. Let's check and make sure the answer is correct here. Okay, yay, I got it right. Alright, so moving on to part B. Oh, I haven't done part B yet. Alright, part B, they want us to find now the distance that it traveled. So which equation am I going to use? Actually, I'm going to use exactly the same equation, only now I put x's and vx and ax and all that in there. So I'm just going to copy the same equation, just replace the letters so they are appropriate for the horizontal direction. I have vx initial delta t, so yeah, minus 1/2 ax delta t squared. Now this time, as before, I know this term goes to 0 because I have no acceleration. So again, if you recall, this is uniform motion, so I could have just gone straight to the simple v equals delta x over delta t equation and solved accordingly. So delta x is going to equal what? My initial velocity, which is 4.5 meters per second, which is also still my velocity when I land down here, 4.5 meters per second, times delta t, which I now know from up here is 3.3 seconds, but I'm going to carry in this whole thing. Since this is an interim value, I'm not going to round and cut off digits because I'll lose precision, so I'll carry this value down in here for the sake of the calculation. If it's still in your calculator, that makes it even easier. And seconds cancel seconds, so I have 4.5 times 3.288, 14.796 meters. Now again, I want to carry about 2 decimal places, so I'm just going to round this to 15 meters. Let's check and see if my answer is correct. 15 meters. Yay, I got it correct.